Hello Dr. Joshua. So I have chosen question 12C from tutorial 2, in which this is the question: xy is equals to xy squared minus y, and hence we have made y as the subject, given that y is equals to 1 when x equals 0 and h is 0.1. I have used the Euler's method in the first one, in which x0 is equals to 1, y0 is equals to 1, h is equals to 0.1, and this is the formula that I have made, in which this is the Euler's method formula. So when n is equals to 0, your xn is equals to 1, your yn is equals to 1, I'm sorry. So firstly, you have to find fxn yn, in which I have found out that from here, which shows that your C17, which is this 1, times by the E17, which is this y1, using according to this formula. Hence I have substituted this xn and yn into this formula and got 0, and I simply just drag it down so that it automatically gives the answer. So hence in the final answer, this is the final answer, which is 1.21945. It is just simply substituting the value of xn and yn into fxn yn, and hence in the last part, finding out your value. The question 12C, which is known as the improved Euler's method. Improved Euler's method, as you can see from the name, it is basically a better improvement into finding out a more accurate value of this y in the end, but as similar to Euler's method. At first, I have already keyed in all the formula, all the value for xn and n, which is from 0 to 5, and then 1 plus h is equal to 1.1, and then so on, and then the value of y0, which is 1. Okay, at first, you have to find out the new value of y by using this formula: yn plus 1 is equals to yn plus hfx and yn, in which I got 1.0. And I simply just drag it down to the algorithm continues to find out all the values of yn, and then the next step is to create another similar answer for the formula of xn yn. However, yn uses this yn. However, in this other function, it uses the new value of y that you have found here by using this new formula. Hence, your fxn yn, from this one, as you can see, you use this formula, which is xy squared minus yx, by using x, and then y squared using this new y value, and then just simply continue minus y over x by using this new value of y, and also this. Hence you have gotten the answer, and then I have finally finalized my answer, which is 1.32597, which is a more accurate answer of an Euler's method, but this is known as improved Euler's method. Third method, which is the RK4 method, in which this is a bit more complex. The Euler's method, as we have discussed earlier, is easy to implement because it only involves linear approximation. However, it suffers from a very low convergence. Therefore, even the Euler's method cannot solve this problem. And hence, in this section, we present numerical methods that have faster rate of convergent, which is RK4 method. So at first, I have created this table, which is xn plus h2, and so on, as well as for yn plus k1 divided by 2, because this is the formula for the RK4 method. We have to find k1, k2, k3, and k4 in order to find the final value of yn. Hence, by creating this table, I have made the table here, and simply just substitute all the values of xn, xn plus h2, yn plus k1 over 2, and so on into k1, k2, k3, and k4. And hence, finally, I have found out all the values of k1, k2, k3, k4 from n1 is equals to n equals to 5. and then in the end, to find the value of yn is basically to follow this formula, which is yn plus 1 over 6, as you can see from this that I've made, plus 1 kyn, which is I8 plus 1 over 6 times bracket k1 plus 2 k2 plus 2 k3 plus k4, which is E8 from all this formula, E8 plus 2 times k2, which is 0.00976, which is f8 times 2 k3 in this value, and also h8, which is k4, 0.02044. And finally, I have gotten all the answers for yn, and simply just drag it down to finalize my answer, which is 1.333. The ABM method is basically a continuation after finding out the value of k from using the RK4 method, in which I have found out these values, which is n, x, n, y, n, and which are the 4 initial points required in the first step in order to generate the points of these points. In order to generate these points, you need the first 4 initial points from the RK4 method. In order to find, so I have done this and this until 1.090, which is basically the same as this. However, how do I continue to finding out n is equals to 4? Which is, the next one is to find out the new value of yn. As you can see from the improved Euler's method, there was also another method that you could find by using the new value of yn, which is the star, which is basically what is the next value that which means you don't have to use the original value of yn from here. So you have to use the new value, in which there was a formula being created, which is yn plus h over 24 bracket minus 9vn minus 3 plus 37vn minus 3, and so on, in which I have found out through here. As you can see, I've applied this formula into here. As you can see, I have I have applied all the formulas from here to finding out my new value. And hence, the next one is to find out the new value for Vn, which is not this, but which is exactly using this formula, which is fxyk, but this is a new method, which is to find out this Vn plus 1 is equals to Vfxn plus 1 yn plus 1, which is basically using the new, this one, which is using this value of xn and this new value of y, in which I have found 1.13176, and hence to find out the converging value, which is the yn, I have used this formula, which is yn plus h over 24 vn minus 2 minus 5. As you can see, I have applied the formula directly here, which is yn plus 1 plus h over 24 times by vn minus 2 minus 5 times vn minus 1 plus 19 vn plus 9vn plus 1, in which I have found out the answer, which is 1.19051, and have repeated the same step for n is equals to 5, in which, and finally I have gotten the answer of 1.33332. Question 9. I have chosen this question, which is solve the system linear of equations. It can be performed or solved by using two methods known as the Jacobi method and the Gauss-Seidel method. It is called the iterative methods for solving the systems of linear equation. At first, we have to make sure that this is a strictly diagonally dominant matrix. What is that? It means that for every row of the matrix, the magnitude of the diagonal entry in a row, which is 2, 1, and 12 in this case, is larger or equals to the sum of the magnitudes of all the other non-diagonal entries. For example, in the first row, 2 is the diagonal entry. The magnitude of 2 has to be larger than the magnitude of 7 plus 1. However, in this case, it is not possible. Therefore, I have to perform an ERO to make this as a strictly diagonally dominant matrix. Hence, I have changed R1, row 1, from this row 1, I have changed it to R2. So by changing the both of them, R1 becomes R2, R2 becomes R1, it is now a strictly diagonally dominant matrix. So how do I perform this Jacobi method? This is how I do it. So at first, okay, let me just cancel that out. So from this, I have performed this by using this formula, which is by making x1, x2, and x3 the subject. x1 here with k is equals to 1, I have just done -1/4 times e6. E6, where is e6? E6 is here, 0, which is x2 plus 1/4 x3 which is here, x3 plus 3/4, and which I have gotten 0.75000. I have done the same thing for x2, which is using this formula instead, and got 2.71429, and I have also used the same formula for x3, which is this, into here by substituting x1 from here and x2 from here into this formula, and I have got 2.58333. And for this, I can just simply drag it down. So I've gotten that, and then just simply drag it down so that it changes again. And then in the last part of x3, I can just drag it down. Therefore, as you can see, x1 is converging to 1, x2 is converging to 2, and x3 is converging. Question B, I have used the Gauss-Seidel method, which is a different approach compared to the Jacob. A Gauss-Seidel method is supposed to be a more possible improvement to Jacobi's method, in which at first I put everything to 0, and then in the first step of x1, I have used the same formula, which is -1/4 x squared, which is h5 plus 1/4 times i5, which is x3 plus 3/4, which is equals to 0.750. However, in x2, I did not use the previous value from x1 and x3. In fact, as you can see from the formula of x2 here, x2 in k is equals to 1, I have used -2/7 times G6, which is 0.750, which is the most recent or the newest value of x1, plus -1/7 times i5, because at first this was not present yet, since I have yet to find out x3 and I'm still trying to find out x2. Hence, I have used the old value of x3. Hence, it is equals to 2.50. And then the next one, as you can see here, let me just clear this out. As you can see from here, I have done it this way: -1/12 to find x3, which is this formula, times the most recent value of x1 plus bracket 3/12 times the most recent value of x2, which is h6 plus bracket 31/12. Hence, I got 3.14583, and here I can just drag this down to the end. So this is the same for this as well as for this. As you can see, the final value here is approaching to 1, 2, and 3. Hence, your x1 is equals to 1, your x2 is equals to 2, and your x3 is equals to 3, which shows that x2 and x3 here, they have used a new value of x1, x2, x3, and not by using the same value of x1, x2, x3 in the first answer. Hence, you have to use the most recent value of x2. Example, you're trying to find here. Hence, you use the most recent value. Like for example, x2, which is -2/7 times x1. Hence, you use this recent value. And then if you find this, then you use this recent value, and so on. Thank you very much. That's all for it.